Hello, my name is Jun-Seong Kim, and I'll be presenting our research, Dr. Splat, directly referring 3D Gaussian splatting via direct language embedding registration. This is a joint work with Geonu Kim, Yuji Kim, Yu-Cheng Frank Wang, Jae-Sung Choi, and Professor Tae-Hyun Oh. Language-embedded 3D Gaussian splatting integrates semantic language features such as clip with 3D representations. This combination allows user interaction with 3D scenes using natural language queries. To achieve this, recent approaches proposes rendering-based distillation, where language knowledge from foundation model is distilled to 3D-GS via rendered 2D feature maps. Typically, this approach involves compressing clip features through per-scene optimized autoencoder. However, there are some limitations in such approaches. First is the reliance on intermediate rendering process. Existing methods are trained based on rasterized 2D images, which is weighted sum of 3D Gaussian features. And due to this intermediate rendering process, discrepancy happens between optimized embedding in 3D Gaussians and 2D clip feature, preventing its application on direct 3D search. To mitigate such discrepancy and bypass the rendering stage, which enables direct 3D search, we suggest registration of clip embedding, which directly assigns 2D clip features only on Gaussians with highest contribution. This is visualization of 3D activation for red cup, for example. We calculate activation of embedding of each Gaussians and visualize them into image by rendering. Here, we can clearly see the problem of discrepancy when we use rendering-based method. Because of this reason, for language interaction, previous method required rendering on all views to obtain feature information. And for full spatial coverage of scene, this rendering process make inefficiency in inference stage. A more efficient alternative would be to directly query in the 3D-GS itself. Searching directly within the 3D Gaussian representation can reduce the search complexity, making it faster than rendering all images. Another drawback is need of per-scene optimization of autoencoder to compress clip features, limiting its scalability and generalizability to new scenes. To bypass this, we suggest a fixed globally shared PQ-based encoder, which is pre-trained on large-scale image dataset, which saves the time required for training each cases. In short, we propose Dr. Splat, a scalable solution that directly registers language embeddings onto 3D Gaussians. Our method includes training-free 3D direct registration method, enabling direct referencing of language features in 3D Gaussians without requiring rendering process, and the generalized product quantization-based encoder, which is pre-trained on large-scale dataset, enabling bypassing of per-scene retraining. Now I will explain the method of our work. Given optimized 3D Gaussians, we first start with constructing a PQ codebook using a large-scale dataset. During PQ codebook construction, we optimize to find centroids of each subvectors segmented from training clip embeddings. And at inference, query embeddings are divided into subvectors and matched to closest centroid to find index of each optimized centroid. These indexes are concatenated to be our quantized feature. Please note that we pre-train this once with a large-scale dataset and share this on every new scenes. And this PQ-based method is scalable as this composes vectors into lower dimensional subvectors, which is much easier than directly compress entire high-dimensional data. And this also boosting representation power for large-scale dataset as it utilizes the combinations of each subvectors. Now I will explain about the training stage. Our feature registration directly associates multi-view clip features with individual 3D Gaussians. Following length split, we first perform SEM segmentation on the images and extract clip features from the mask regions of each object. Then, for each pixel array, we find corresponding clip features and the top K Gaussians with highest contribution. We construct binary masks to indicate top K Gaussians. Next, we aggregate this embedding across multiple views using weight derived by volume rendering equation and binary mask. Finally, we compress this aggregated feature through pre-trained PQ inference, registering compact feature indices directly into 3D Gaussians. Now, each Gaussians have its features enabling 3D querying without additional rendering. In our experiment, Dr. Splat significantly outperformed previous method for 3D object selection tasks. Lang Splat often produced noisy activations, while Open Gaussian incorrectly selected nearby objects. Our model accurately localized only the intended object. Dr. Splat also achieves superior performance in 3D localization task and open vocabulary semantic segmentation task compared to the prior method, and it demonstrates its robustness in complex 3D structure. And Dr. Splat works even in large city-scale cases, demonstrating its scalability. Please note that we don't utilize per-scene retraining in these experiments. In conclusion, we presented Dr. Splat, which enables efficient open vocabulary 3D search without rendering process. And we construct universal PQ-based encoder, which provides scalability without additional per-scene training. For further details, please refer to our project page via the QR code. Thank you for listening.